Hey everyone, in this video we will discuss all the previous year questions from Mixture and Alligation chapter which have come in past year papers of CUET PG MBA. Now before we start questions, so let us discuss first the past year breakup, year-wise breakup. So in 2022 we had two papers, first on 12th September, second on 5th of September. So in 12th September we had one question, in 5th September we had three questions. There were no questions in 2021 and 2020. And there were one questions on 2019. So in total there were 5 questions. So we will discuss all these 5 questions one by one. Now before we start questions, I would invite you to join our Telegram group. So there would be quizzes as well, especially on verbal section. So if you are preparing the topics like we have one word substitution, right? Then we have sino ento, then we have idioms and phrases. So all these topics we will do quizzes from tomorrow onwards. So it will be highly beneficial for you if you join this Telegram group. I will put this link in description. Okay, so now we can start our questions. So the first question is from CUET PG MBA 2022 12 September paper. The question says a mixture of 60 kilograms of rice and dal contains 45% of dal. The new mixture is found by adding 15 kilograms of dal. What is percentage of rice in the new mixture? So this question is of invariants. So if you have watched my video on percentage chapter, so there also I have discussed this question. So this question can be discussed in as a percentage question as well or mixture and alligation question as well. So I'm repeating this question. So we have a concept, very beautiful concept known as invariant. The quantity that does not change. The quantity that does not change. Now once you read this question, so we have rice and dal. R for rice, D for dal. Okay. So it is dal is 45%. So obviously rice would be 55%. The new mixture is formed by adding 15 kilograms of dal. So whatever dal we have, I am adding 15 kilograms of dal. What is the percentage of rice in the new mixture? So whatever the new mixture is, what is the percentage of rice in that new mixture? So if you notice here, the quantity of rice here, quantity of rice, let's call this initial mixture IM, and let's call this final mixture FM. So can I say that the quantity, whatever quantity of rice is there in the initial mixture, the same would be in final mixture, right? Because I am not changing the quantity of rice. Whatever I have added, it is added dal, right? So quantity of rice does not change. So we can say that quantity of rice doesn't change, or we can say that quantity of rice is an invariant here because it doesn't vary. Now we can solve this question. So let's move on to next page. We can solve this beautifully. So we have 60 kilograms of rice and 45%. Okay. So we have 60 kilograms rice plus dal. I'm denoting rice by R and dal by T. Now let's move on to dal and rice. So this is 45%. This is 55%. I'm adding 15 kilograms of dal. 15 kilograms of dal. So basically this would become 75 kilograms, right? And here I want to find rice percentage. Okay. So the invariant that I have said earlier, that quantity of rice in initial mixture will be same as quantity of rice in final mixture. Now what is the quantity of rice in initial mixture? So 55% of 60 kilograms, right? 55% of, or let's replace this of by multiplication sign, right? 55% of 60 kilograms equal to, what is the quantity of rice in final mixture? So we know that total quantity is 75 kilograms and we have to find the rice percentage. So let's that percentage is x percent of 75 kilograms. Now my answer would be x, right? So we have to simply solve for x. Now it is very easy. See, this would get cancelled or percentage. 15, 5, 15 into 4, 60. 5, 11 ja 55. So therefore x would be 11 into 4, 44%. So this is our answer. So which option? Option D. Now this was method 1, invariant method. So you can solve it in another ways as well, but that would be very basic one. What you can do is you can find quantity of rice, right? Quantity of rice and dal. So this is 45%. So if you find 45% of 60, so 45 by 100 into 60. So 3, 5, 9, 27. So this is 27 kilograms. So obviously this would be 60 minus 27, 33 kilograms, right? If you add 15 kilograms of dal, so if you add 15 kilograms of dal, now see, you don't have to worry about dal actually. So your focus would be on rice now. So 33 kilograms of rice, and now out of total 75, then what is the rice percentage? So 33 by 75 into 100. So 25 into 4, 25 into 3, 11, 11 into 4, 45. So this was method 2. But if you notice here, I had to calculate first the values. This is your method 2. But if you notice here, I had to calculate first 27 kilograms, right? The value of rice and dal. Then I had to add this 15 kilograms. Then at last I had to find percentage. But here I can get my answer in one shot. One equation I'm writing only one equation and I'm getting my answer. So that's why this is certainly a better method, the invariant one. So you should, whenever you find that one quantity is not changing, you should always apply the concept of invariance. I hope you understood this concept well. Let's move on to the next question. In a mixture of milk and water, there is only 26% of water. After replacing the mixture with 7 liters of pure milk, the percentage of milk in mixture becomes 76%. The quantity of mixture. Okay. So this question is from 2022 fifth November paper. Now this question is on replacement. And for replacement, you need to know the concept of proportions. So let us discuss. Let's say here we have milk plus water, and we have 26% of water. 26% water. What I do is I subtract my minus 7 liter from mixture. I took out 7 liter of this mixture, and then I added 7 liter of pure milk. So there are two operations. I am removing 7 liters of mixture and then I am replacing it with 7 liters of pure milk. After this, I got 76% of milk. So what is the percentage of water, right? So percentage of water would be reduced by, so it is become 24% water, because 76% is milk, so 24% of water, so 2% reduction in water is there, right? Okay. Now for replacement questions, what we do is we find the quantity which is not being replaced, or you can say which is not being added. So the addition is of pure milk, right? So in this mixture, whatever I am removing, let's say this 7 liter portion, so both will be removed, milk and water, in the same ratio, this ratio, because in the mixture the ratio doesn't change, right? So in the same ratio milk and water would be removed from here, but I'm adding pure milk. So it means that water percentage will obviously reduce, right? Water percentage will reduce. Why? Because I'm taking out some water in this mixture, some water is also going in the same ratio, but the addition portion is simply milk only. I'm not adding any water, so obviously water percentage will reduce, and you can see it here also. 26% water has reduced to 24% of water, right? Okay, let me erase this. This should be more clear. So this is 24% water. So from 26% water, I have reduced it to 24% water. Why? Because I removed some quantity of water and milk, but I'm adding milk only. So that water is gone. Okay. Now what will what we will do here is, so we will try to focus on water percentage because this is getting reduced. So can I say that water proportion? Now proportion is nothing but the fraction, you can say, right? So 26%, can I write this as 26 by 100? So this will be known as my proportion. So water proportion initial, that is in this mixture, into some fraction, and this will give me water proportion final, right? What is my initial proportion? 26 by 100 into, let's say this fraction is f. Okay, I'm denoting this fraction as f, equal to water proportion into final. So water proportion final is 24 by 100. Now I can cancel this out, I can cancel this out, 12, 13. So what is the fraction? So fraction is 12 by 13. So this fraction denotes that I am reducing my mixture by 1 by 13, right? So my earlier mixture was 13, but my new mixture is 12. So I can say that 1 by 13th portion is reduced, right? So 1 by 13th portion is reduced, but that portion is 7 liters of fuel, right? So we can say that 1 by 13th, 1 by 13th of total quantity is nothing but 7 liters. So therefore my total quantity would be 13 into 7, 91 liters. And this is what we were asked. We have to find the quantity of mixture. So we found that 1 by 13th portion is being replaced. Why? Because 12 by 13th portion is there only. So 1 by 13th portion is being reduced, and that portion is given as 7 liters because that is the part which is being replaced by pure milk. So we equated that 1 by 13th of total quantity is 7 liters. So obviously total quantity would be 13 into 7, 91 liters, and the option is B. Option B. So I hope this is clear to you. What we do is we equate initial proportion to with final proportion, and the quantity that we focus on is the quantity which is being changed, right? So water proportion is being reduced here, so we will focus on that. Okay, I think now we can move on to next question. This question is on 5th September paper. 4 kilograms of a metal contains 1 by 5 copper and rest zinc. Another 5 kilograms of metal contains 1 by 6 copper and rest zinc. The ratio of copper and zinc in the mixture. Okay. So let's say metal 1, metal 2. Metal 1 is, let's say I'm denoting copper by Cu and zinc by Zn. Copper and zinc. So 1 by 5th portion is copper. 1 by 5th portion is copper. So obviously this means that this is 1. So this would be 4. Right? Total is 5. 1 by 6th of copper. 1 by 6th of copper means 1 is to 5. Right? So we got ratios done. So we are done with the ratios. We have found the ratios of copper and zinc in both metals. Now the thing here is that this will be 4 kilograms and this would be 5 kilograms. Now in such questions, whenever we mix them, we are mixing them up, right? So the first thing that we do is we always make sure that the sum of these ratios are equal. So if you add these ratios, we get 5. If you add these two ratios, we get 6. So our first job is to make these two same. And how can we make these two same? I will multiply this by 6 and I will multiply this by 5. So my both sum would be equal to 30. Right? So 1 is to 4. You multiply this by 6 and 1 is to 5. You multiply this by 5. from here new ratio would be 6:24. From here new ratio would be 5:25. If you add these two, then you will get 30 here and 30 here also. Now we are safe to perform any operations on this. Now thing is, I'm mixing this 4 kilograms of this, and for this I'm mixing 5 kilograms. So now I will have to multiply this portion by 4 and this portion by 5. So from here we will get 24 is to 96. 5 120, sorry, this would be 25 is to 125. So this is copper, this is zinc. Now I can simply add them up for mixture. So if you add these up, then you will get 49 is to 1 2 to 1. 49 is to 2 to 1, 221. So that is option B. So whenever you are mixing two different type of mixtures, I will note down these steps. So your steps would be, always focus on the first step. The first step, some people skip this step and that's why they make mistake. Your first step should always be that the sum of ratios should be equal. Sum of ratios should be made equal. If they are equal, then well and good, but if it is not, then it is your duty to make them equal, right? Because if you notice here, sum of ratio was 5, sum of ratio was 6. So we can't be sure that if we perform any operations, it will do the justice, right? So the thing is, you should always make the sum of ratios same. So that's why here we have to multiply by 6 and here we have to multiply by 5. Now what's the second step? Now the second step is that, are you mixing the both metals, or you can say any mixtures? If you are mixing them, then are they in the same ratio? Or if they are not in the same ratio, for example here the ratio is 4:5, right? Here I had to mix this 4 kilogram and for this one 5 kilogram. So the ratio is 4:5. So in the second step we will mix them in the ratio. Mix them in the ratio given. Suppose these two things were not mentioned, that how many kilograms. So in that case we will assume that both are in the same ratio, right? So in that case we don't need to perform these two steps, this step, this and this, and then adding up. I could have added here only, because both are in the same ratio, so we can add them up here only. But here, since the ratio is 4:5, so I had to multiply. So these two steps are there. And for the third step, you can say that you can simply add the ratio. You can add the ratios directly. You can add the ratio directly now. So in order to perform this last step, that adding those two ratios, you need to perform these two steps, because you can't add ratios directly, right? So these two steps are very important. And whenever you do these two steps, these three steps, you will never make a mistake in such questions. Whenever you are mixing one type of mixture or one type of metal with second type of mixture, these steps are common in all such questions. Okay, so now I think we can move on to the fourth question. This is from 5th September paper 2022. A vessel is filled with liquid, 3 parts of which are water and 5 parts of syrup. How much mixture will be drawn and replaced with water so that mixture becomes half water and half? Again the same question. This question we had discussed, right? Notice here this question, this fraction one, initial proportion and final proportion. So again we can apply the same technique here. Okay, 1 second. So there is a vessel and there is water and syrup. So the ratio is 3:5, water and syrup. Here I have to replace with water, so that water is half and syrup is half. So new ratio would be 1:1, water to syrup. Now since you are replacing it with water, obviously syrup will reduce, right? Syrup will reduce, and you can observe here also currently syrup is 5 by 8. This is more than 50%, right? And here we have half, so this is 50%, but this is more than 50%. This is, I think, this would be 62.5%. So since you have replaced this mixture with water, obviously syrup concentration will go down. So again, same technique. So I am denoting syrup you can say proportion by SP, syrup proportion initial into some fraction, you can say, and then we will get syrup proportion final. What is initial proportion? 5 by 8 into this fraction equal to half. Final proportion is half, right? So 4 times, from here we get the fraction as 4 by 5. Now what this fraction denotes? This fraction denotes the proportion after, you can say, after replacement. So what we can say is I am reducing 1 by 5th, right? 1 by 5th reduced. It means that 1 by 5th portion of mixture is being replaced. So the answer is 1 by 5th. So you should be clear with this. You should always be clear with this fraction, what this fraction means. Okay. So this fraction you can denote it like F equal to V1 by V2, where V2 will always be greater than V1. And what is V1 and V2? V1 is volume before adding and volume after adding. Okay. V2 is volume after adding. So once you have removed this portion, so this would be V1, and this V2 would be that you have replaced it, right? So after replacement, this volume would be, so obviously this volume will be more. So you should always take note of this. Okay, I hope this is clear now. I think now we can move on to the next question. Okay, the next question is from 2019 paper. The ratio of milk and water in 55 liters of adulterated milk is 7:4. How much water must be added to make the ratio of milk and water in the mixture 7:6? Okay. So we have 55 liters and 7:4 ratio milk is to water. How much water plus water? How much water we should add so that this ratio becomes 7:6? So obviously since you are adding water, so concentration of water will improve, right? So if you notice here we have 6 by 13 water and here we had 4 by 11 water. So obviously this is improved one, because 1 by 11 is 9.09. So this would be approximately 36.36%, but this would be nearby, this is nearby half, right? So this is nearby 50%. So you can say 46 or 47%. So obviously water has improved because you are adding water. Okay, now let's solve this question. So how can we solve this question? See, this question is again, I think it was the first question that used the concept of invariants, right? Can you identify the invariant here? Means the quantity which is not changing. So it is easy to identify here that I am adding water, right? And I am not even removing any portion of this mixture. So obviously the quantity of milk here, whatever quantity of milk is here, this would be here as well. Quantity of milk would be same in the final mixture and initial mixture. So quantity of milk in initial mixture will be equal to quantity of milk in the final mixture, because I'm not doing anything with my milk portion. I'm simply adding water. So it means that quantity of milk doesn't change. Quantity of milk doesn't change, and that is the invariant portion, right? So quantity of milk is 7 by 11 into 55 kilograms equal to quantity of milk in final mixture. Quantity of milk in the final mixture would be 7 by 13 into. Okay, now what is the total volume? So total volume is 55 plus, let's say I'm adding x liters of milk, right? So now we can solve this. So 5 times this would get cancelled out. So 5 equal to 55 plus x by 13. So 13 we can cross multiply. So we will get 13 to 5 65 equal to 55 plus x. So we can say that x equal to 65 minus 55, 10 kilograms. So it means that we had to add 10 kilograms of water. 10 kilogram of water is added. So option. So I think we have discussed all the questions. So in total there were 5 questions. So number of questions were less. In percentage, I think we had done 14 questions from 2019 to 2022 papers. 2019 to 2022 papers. So there were 14 questions in percentage. So by the way, if you have not watched this video on percentage, so you can go and watch this video. This is available in our playlist, or if you go to our channel in video section, then you will find the video on percentage. Same way, we have discussed all the previous year questions. There were total 14 questions. But in mixture and integrations, we got only 5 questions. But I'm sure that you have learned something new and all the concepts are clear. The concepts of invariants, the concept of replacement. These two are very, very important. And this concept of mixing two metals, or you can say two mixtures. So these 3 steps, all these are very important concepts. And you should not by heart all these things. You should understand these things. That is the better thing, I would say. People generally remember the steps, but why we are doing that, that is more important, right? So I'm sure you have learned some better methods here. So let's meet in the new video. We will discuss similarly for other chapters as well. So we have done for percentage, we have done for mixture and delegations, we will do for average, profit loss, simple interest, compound interest, time, speed, distance, trains. Then we have algebra. So in this year they are not mentioned these topics like algebra, mensuration, geometry, but I think that is a typo. Most likely they will ask the questions. So let's not forget those chapters. It is better that if you are done with the chapters that is mentioned in the syllabus, it is safe side that you should do other topics as well. So thanks again. Let's meet in the next video. So thank you.